Okay, so it feels like every single week there's a new AI coding tool, right? But today, we're looking at something that, well, it behaves in a completely different way. This is not just another chatbot. This is Google's Antigravity, and it's less like an assistant and more like having a small engineering team living right inside your editor. Let's break down how this AI engineering team actually works.
We're all pretty familiar with the model on the left. You type a prompt into a single chat window, one AI model thinks for a bit, spits out some code, and then just waits for your next command. It's a very linear, one-on-one conversation. Anti-gravity, on the other hand, just completely redefines that whole interaction. It's designed to operate like an entire team of AI agents that can collaborate, build, test, and even report on their work all at the same time.
So here's what we're going to cover in this explainer. First, we'll dive into why this is such a huge leap beyond a simple chatbot. Then we'll introduce you to your new AI engineering team and the kind of mindset you'll need to manage it. After that, we'll walk through a typical workflow from a basic idea to a finished product. And finally, we'll look at one of its most powerful features, code that literally tests itself.
And I really want to be clear here. This is not some small incremental update. We're not just talking about a smarter autocomplete or a slightly better chatbot. No. This represents a really fundamental shift in how developers can interact with AI. We're moving away from a simple assistant that you give tasks to and toward a partner that you actually strategize with.
The big idea behind all of this is what's called an agentic IDE. What that means is it's a development environment built from the ground up for multiple autonomous AI agents to collaborate. They don't just write code in a vacuum. They can work in parallel on different parts of a project, test their own work, and even fix the bugs they find along the way. So, how does this AI team actually work? Well, it all operates across three main components. You've got a manager, an editor, and a browser. You can think of these as the different departments of your virtual engineering team, all working together perfectly in sync. First up, and this is probably the most important part, is the agent manager. This is your mission control. Instead of a single chat window, you get a whole dashboard where you can launch new agents, give them different tasks, check on their progress, and review their work, all from one place. You're not just a coder anymore, you're the project manager. Okay, then you've got the editor. It looks familiar, sure, but now it's basically your workbench, populated with these AI agents ready to refactor, debug, or build whatever you tell them to. And then there's the browser. And this is where the real magic happens. Antigravity can launch an actual Chrome browser to interact with your app, testing it just like a real user would, and then reporting back with super detailed feedback.
Now, using a system like this really does require a bit of a mental shift. You have to stop thinking about crafting that one single perfect prompt. Instead, you need to start thinking like a manager who's guiding an overall strategy. You're orchestrating the team, not just talking to one employee.
One of the sources we looked at put it perfectly. They said using it feels way less like chatting with a bot and way more like reviewing a junior engineer's PR. And that just nails it. The AI doesn't just hand you a block of code. It presents a whole plan and it's finished work for you to review, almost exactly like a pull request from a human team member. And the way it presents this work is through something called artifacts. So instead of a long, messy chat history, the agents generate actual structured documents. You'll get an implementation plan before they even start, a clear task list of what they're doing, and a final walkthrough with logs and even GIFs of the finished product. This keeps you in complete control the entire time. And get this, you're not even stuck with just one AI model. This system lets you use different models for different jobs. It's like building a real team. You can assign Gemini Pro to handle the front-end UI because it's great with design, give Claude the complex back-end logic, and use GPT-4 as a reliable coder for the simpler boilerplate stuff. You're literally matching the right talent to the right job.
All right, so we've got the big ideas down. Now let's see how all these pieces actually come together in a practical workflow to build a real application from scratch. The whole workflow is actually pretty straightforward, following what the sources call the flow framework. First, you frame the problem you want to solve. Then you provide the layout. This can be anything from brand guidelines to just a couple of images for inspiration. Next, you orchestrate your team of agents to build everything out. And finally, you review all the plans and artifacts, making comments and giving the final thumbs up.
Now, with a traditional AI assistant, building a full application is always sequential. You do the back end, then you do the front end. But when you have an entire team at your disposal, well, it makes you ask a totally different question.
I mean, think about it. You can spin up multiple agents at the exact same time. So while one agent is setting up your backend API, another can be building the UI components. You could even have a third one researching best practices for a tricky feature, while a fourth agent sets up the database schema. This parallel execution is where you get this massive, massive speed advantage. Okay, but now we get to what might be the single coolest feature of this whole thing. We've talked about planning and building, but what about making sure the code actually works? This is where that autonomous advantage really shines.
It's this idea of self-healing code. The browser agent can actually run through your application, and if it finds a bug, let's say a button that doesn't work, it doesn't just report it and stop. No, it analyzes the error logs, looks at the code, figures out the root cause, and then tries to generate and apply a patch all by itself. Then it reruns the test to see if the fix worked. It's incredible.
And we're not talking about some abstract simulation here. This browser agent can perform real-world actions. It literally opens a Chrome window, clicks on buttons, fills out forms, and tests entire user journeys from start to finish. And it records everything with GIFs and detailed logs to show you exactly what it did, what worked, and what broke. It completely closes the loop between writing code and knowing if it's any good.
One last thing, and this is super important. This isn't some walled garden. It uses something called the Model Context Protocol, or MCP. Just think of it like a universal translator that lets your AI agent securely connect to and use the external tools you already use every day. Tools like GitHub, Vercel for deployment, or even Airtable. This plugs your AI team into your entire development ecosystem. And that quote right there really brings it all home. We are so far beyond simple autocomplete now. We're entering a world where the key question for developers is no longer just, what's the best prompt? But how do I become the best manager of my own small virtual engineering team?